We start, we are a bit late. So welcome everybody again. It's really nice to see real people after 2 years. So this is the ICT infrastructure for road transport session. My name is Andrea Arcelli. I'm project manager at Cinea, where I'm in charge for the whole portfolio of logistic project in Horizon 2020 before, and now Horizon Europe. I will be moderating this session together with Thorsten Geisler, and we have the other speaker that I will introduce immediately after. Thorsten has an extensive ITS experience, more than 25 years in ITS. He's working for the German Federal Highway Research Institute, where he's deputy head for the Connected Mobility Department. He will help me in moderating this session, and he will be leading the Q&A session at the end. The other speakers for today are starting from the left of Thorsten is Vasilis Zurlas. Vasilis is senior researcher at the Institute of Communication and Computer Systems in the National Technical University of Athens. He has an extensive experience in ITS projects and is coordinator of several of the ITS projects that are currently running. Then it's Kostas Davitsas, is a senior teaching fellow at the Imperial College. He's also working for VLTN here in Belgium, and has an extensive experience on IE and artificial intelligence, in particular for application on modeling transport networks and supply chains. And last but not least, we have Gerasimus Columbis, that is Program Delivery Director at Illecom, is a coordinator of several projects, among those also Econet and Plan that will be presented today. I have previous experiences in IT, and he will give us the presentation later together with Kostas. So I will reduce a little bit the presentation I was thinking to give, just to give a little bit the policy background of these three projects. We have two projects. One is Econet and Planet. They are, of course, in the domain of logistics, and the ICT for CART is on automated transport. This project, what is of course, the overarching objective ahead is the Green Deal objective to have a European Union climate neutral for 2050. But of course, this is the overarching objective. If you want to go to a more operational level, of course, we have the Sustainable Smart Mobility Strategy that was approved in 2020, December 2020. And if we look at this strategy, we have one of the building blocks is taking the opportunity of digitalization and automation. So the scope is, of course, to create an ICT backbone on which all the services on transport will move a leap forward in the near future, hopefully. And also, this is, of course, true for sectors that are ICT demanding, like automated transport, but this is also true for a sector like logistics that is traditionally more conservative. So without further ado, I will pass the floor to the first presenter. I think we start with, who's the first project? I think according to the planning, it should be Planet. Yeah, Iconet, okay, Iconet. And I kindly ask the speaker to stick to the 15 minutes because we are a bit late. I will give you maybe a reminder 2 minutes before the end of the time, okay? Oh, the clicker is there.
Okay, what does it do back? Okay, so good morning everyone. My name is Gerasimus Kolumbis. I'm representing Illecom, and I will be presenting two projects today together with Kostas Davitsas, who has been a senior researcher in both of the projects, and I've been the coordinator of those two projects. The first project I will be talking about is Iconet, and let me start right away. So, Iconet, sorry. Okay, so the Iconet project is a project that started 1st of September 2018. The duration of the project was 30 months. Yeah, please.
Because we are streaming, so only if you switch to the microphone.
Okay, thank you very much. So,
We can set up.
yeah, okay. All right, so the duration of the project was 30 months, so the project has ended more than a year ago. The overall budget was approximately 3 million, and it consisted of 16 partners. Details on the project you can find on the relevant website, which is still live. Just to mention a few of the partners, apart from Inlecom, who was the coordinator, there was Procter & Gamble and Sonae from Portugal, Stockbooking from France, and we also had the Port of Antwerp, and several technology and consulting partners like IBM in Ireland. Now, what was the project vision for ICONET? It was to explore and create innovative PI network services that optimize the cargo flows and get throughput, cost, and environmental performance based on governance policies and SLAs, having always awareness of the status of the network operations. This was done through three major pillars: building new business and governance models that enable the PI operations, a generic PI case study and simulation models that representing the physical internet world and the network design, and finally an open reference architecture which enabled the connectivity at the digital level. Now, more specifically, the objectives, some of the highlights of the objectives involved the prototyping and communication of the functionality of the PI services that enable the physical internet, mainly dealing with four of the layers. I will explain the physical internet layers a little bit in the next slides. Standardization of data structures and transport network features, and as well as services and variations, such as those involved for routing of long-haul distribution for the last mile. We also determined the operational workflows for business-as-usual logistics and extensions for unique PI services. We applied the PI principles in four use cases, four scenarios practically: one long-haul intra-EU transport, warehousing as a service, last-mile distribution for e-commerce scenarios, and one for the physical internet hub. We also identified the physical internet roadmap and how it will enhance the strategic evolution of the transport and logistics sector in Europe. Now, a little bit more details on the key outputs. We defined best practice for designing PI hubs, corridors, e-commerce, and warehousing as a service. We demonstrated the PI case study, and we also highlighted the key features of PI hubs plan. As far as the technology dimension, we built these reference architectures built on open standards and simulation services which demonstrated and quantified the efficiencies introduced by the physical internet. And we did measurements in the living labs as far as increase in load factors, increase in operational efficiency, reduction in CO2 emissions, and we also logged the lessons learned from our stakeholders. Of course, there were commercialization and impact assurance activities. We had 6 publications, strength and weaknesses analysis, conferences, we liaisoned with organizations like ALICE and ERC. Now, a very brief outline just to set the stage for the services that were implemented. The physical internet has been built in analogy with the digital internet. So in analogy with the OSI layers, we have the OSI layers in the physical internet. The project dealt with the 5 top layers, which included the web logistics layer. We did services on smart contract management, the capsulation layer, which is about the packaging of the goods, and we did the wagon load optimization services, the shipping layer, which is primarily dealing with preparing the orders and monitoring the delivery of the goods, where we did end-to-end track and trace services. The routing layer, which is about creating the path from A to B for the cargo to be delivered, where we had the short path, multimodal shift cargo consolidation services. And finally, the network layer, which is the layer which informs on the status of the physical internet and involves the discovery of the actual network and providing a real-time up-to-date status of the network itself. This is, let's say, an information layer which gives data for the routing to execute, to plan ahead the delivery from goods from A to B. Now, the test ground for this particular project were 4 living labs. One was built around the Port of Antwerp, which the main let's say, target was to validate the capabilities of hubs and identify possible topologies, as well as test synchromodal principles based on the physical internet. We had a living lab on a long PI corridor, which was around a Procter & Gamble use case, and looking on the prospects of transforming TNT corridors into PI corridors through the use of IoT-enabled services. We had a living lab in Sonae in Portugal, a supermarket, where we tested the application of the physical internet principles in urban distribution for an e-commerce use case, and studied the impact of those principles and redesigning the last mile distribution. We will hear details later on from Costas. And we also had the warehousing as a service implemented in France in collaboration with Stock Booking, where we investigated the role of the warehouses as a key PI node and acting as a dynamic buffer for flows among the physical internet hubs, allowing to increase the throughput and reduce the congestion. Now, I know that this cannot really be read. This is a very simple example of an indicative example of the workflow. It's a sequence diagram which shows the interaction among the various layers, starting from the left where the freight forwarder submits PI transport orders to the web logistics layer. This, let me zoom a little bit. This is transformed from the web logistics layer to a smart contract, which it becomes in the shipping layer a PI order. Then the encapsulation layer adds in the PI order an assigned PI container. The whole process, if you would see in the previous diagram on the top right, on the far left, on the far right, there is the IoT, the cloud infrastructure, which feeds with events the network layer, so that you are aware of the status of your network as well as your cargo. And this information goes together with all the data of the network to the routing layer, where you can where the planning of the routing is happening. This is just an indicative flow, just to understand how the interaction between the various layers and services act. Okay, now Costas will give you some highlights of the key outputs of the project.
I'll have this one. Can I have the slides?
Yeah.
Hello, everyone. So when we're talking about the physical internet, we are talking about a completely different way to undertake and for the logistics business to work. And that means that we stop having the direct transport from origin to destination, and we are adopting a much more indirect, multimodal, from hub to hub approach. And this is something that needs to be integrated, in essence, in the design of the network. So we stop having direct transport by truck, and for example, we are encouraging, as I said, multiple hubs, multiple stops, and more efficient and higher utilization rates in our transport. And again, this aligns with the concepts of the physical internet, to have open warehouses, open transport, have multimodal capability, enable IoT, and also have modularized containers. So not just the 20 and 40 foot containers that we use today, but much more refined versions of it. So there are basic principles that are very different in the physical internet, and even at a strategic level, you have to consider that and I'll make the network appropriate. Now, starting from the network representation that Mike has just introduced, the basis for that was to define a common data framework. So we started by identifying, first of all, the components of the physical internet, and we broke them down to physical internet nodes, and that could range from small warehouses to large mega hubs like ports of Northern Europe. We also identified the links. Again, this could be multimodal. And also we have the physical internet movers, so all the transport means that are eventually carrying the cargo. Now, in terms of data, on the one side, there is a static data that the network has. It's about network infrastructure, the origins, the destinations, the capacity of warehouses, their capabilities, the lanes in a highway, for example, or the number of corridors. But there is also dynamic data, and in essence, these are the type of data that we need to keep updating, we need to keep tracking in the network in order to enable the physical internet functionality. So here we are talking about queues at various warehouses, loading capacities, congestion levels, travel times at specific links, weather conditions, of course. So there is a set of data that need to be continuously monitored, and the networking service, in essence, is responsible for passing on this data set. Now, when we're looking at mega hubs, we have even more issues. So one of the living labs was the port of Antwerp, and we quite quickly realized that by modeling it as a single point in the map is nowhere near sufficient. So we had to adopt what you see in the image on the right, which essence break down the mega hub into much smaller terminals. And interestingly, we also broke down the link. So whenever we had a transshipment, because the physical internet is transshipment based and encourages this hub-to-hub movement, we started counting the transshipment cost, the transshipment time, the unreliability, whatever metric there was to consider in the transshipment aspect was also taken into account. And we also realized that those mega hubs have infrastructure limitations. So again, we tried to look those red boxes that you see along the links, which are infrastructural limitations. They could be bridges or tunnels or corridors eventually that have a specific capacity. And this is eventually the level of representation that we need to capture to understand the functionality of those hubs. Now, in a more operational level, those hubs need to be analyzed, and whenever we have arrivals of large vessels, for example, we will unload on containers, and then we will need to distribute those containers to the appropriate means for hinterland transport. So again, this was part of the encapsulation service of the physical internet, and this is the work we did in ICONET. And in essence, as I said, the 20 to 40-foot containers, but also the subdivisions, we needed to figure out when and where each of those sub-containers needed to go. So we had the development of bundling algorithms for trains and containers, and we integrated this functionality as smart functionality in the encapsulation service. Now, another interesting living lab was that of Sonai and e-commerce in the last mile. And here, one of the major challenges that we were given was that of stockouts. So as part of the shipping layer of the physical internet, we tried to work out a solution around it. And we came up with a smart assignment algorithm that would, in essence, pair specific warehouse locations to customers. And it will do that optimally with the aim of reducing stockouts. And we were quite surprised to realize that the effect was significant. So we had a 90 percentile reduction in stockouts, which was quite interesting. And again, that was achieved by opening up multiple warehouses and tracking the stock level of various SKUs. Now we also looked into network expansion, again in the last mile, so you can see how the network becomes more efficient as we move from the left to the right, as more warehouses become available and open for business in this physical internet. So the distance to the customer and the routing required reduces significantly with more locations being available. And again, we worked around a facility location problem to identify where these locations should be. Yeah, Mikey, back to you.
Okay. Thank you. So, one of the last outputs of the project involved the definition of an interoperable IoT architecture that supports this goods encapsulation, as well as the monitoring, tracking, and trace of the services. This architecture allows for a dynamic, ad hoc, secure connection of each stakeholder with the IoT data. And as part of this work stream, we also developed custom IoT hardware, a tracker, and a container gateway. Now, as part of the project, the outputs were, we also had 4 patents. One of them was actually recently granted. So innovation is protected for Europe. And And going back, closing with the long-term mid and long-term expected impact of the project, as regards the technological, we are looking for a better understanding of the PI service and functionality and workflow, along with the respective data structures, innovative IoT for container monitoring, dynamic and secure tracking and tracing, and also multimodal, multi-agent simulation models that evaluate the impact of the PI services. From the perspective of the society, this allows the better understanding of the collaborative rules that apply under the principles of the physical internet, as well as measurable KPIs for the adoption of the physical internet in multiple use cases, as I mentioned, warehousing as a service, replenishment strategies, and damaged goods, for example. We also had open data available at the end of the project. As regards the economic, we have realized through simulation primarily, improved efficiency through lower shipment costs and universal access of resources. We optimized the PI routing and PI hub resources, and we demonstrated the value proposition of the PI services in the living lab cases. Finally, for the environmental impact, we are talking about reduced carbon footprint, primarily coming from optimized collaborative cargo encapsulation and routing. So basically, increase load factors and optimize routes. Now, as far as future research needs, we have recognized the need for implementation and extension of the PI principles to the last mile, considering warehouse collaboration, SKU and vehicle tracking, implementation of smart algorithms, as well as wider scale simulation models, including geopolitical parameters, which we will see in the next project. And as regards the market uptake, solutions that can be adopted by the market, we are talking about wagon and container bundling, optimal pairing of orders and picking locations to minimize stockouts, new e-commerce hub location selection optimization, and disruptive business models focusing on monetary value chains linking with the transport and logistics sector. Thank you very much. Hope I was on time.
Perfect.
Yeah, I thought there was going to be an interactive question session.
Oh, is it the end?
That's at the end. Okay. All right, so moving on. It doesn't react. Okay. All right, perfect. So, evolution of ICONET is the project Planet. It's a project that started at the beginning of June 2020. The duration is 3 years. The project is still close to the end of the second year. The overall budget is 7 million. And now we have practically double the size of the partners and double the size of the project. We have now as primary users DHL and Costco in Spain, Port of Rotterdam, UPAC, the Polish National Post, City Login in Madrid, and various actors like GS1, European Shippers Council, IBM, Itainova, and multiple technology partners. Now, the Planet Vision is all about advancing the European Commission strategy for smart, green, and integrating transport and logistics. This will be done through two dimensions. One is efficiently interconnecting infrastructure, and by infrastructure we are talking about TEN-T and rail freight corridors with geopolitical developments, which means refer to future new Silk Road and emerging trade routes, and optimizing the use of current emerging transport modes and technological solutions, respecting the certain principles such as ensuring equitability, inclusivity for all participants, increasing the prosperity of the nations, preserving the environment, and enhancing citizen quality of life. Now, this is a little bit dense slide. I will just go very fast through the key objectives, where the first two pillars are dealing with the modeling capacity and simulation capacity, and the second is the technology dimension. For the first pillar, we are talking about end-to-end transport chain models, including last mile and ocean shipping, which are utilizing technologies such as IoT, blockchain, and AI. We are also looking for synchromodality on blockchain-enabled platforms. We are measuring and monitoring the connectivity of principal nodes through the definition of an index on that we will talk about later. We are looking on warehouse operations planning and space capacity quantification. And we also have simulation models for global and 10T corridors to inform the network design and impact of the innovation. This is the modeling and simulation part. As far as the technology, we have already built a pub-sub platform with privacy-preserving data sharing. We have a connectivity infrastructure for semantic interoperability. We are implementing an interoperability layer supporting federation of blockchains, so blockchains talking to each other. We will also see that later on. We have the evolution of the IoT architecture that we had in the previous project, and a prototype implementation utilizing GS1 standards in the Polish Living Lab. We have predictive and optimization analytics components to support the PI models, multi-criteria decision support systems, a unified human-machine interface, and all those will be measured with KPIs we have defined, and we have set targets in the living labs, which recognize significant improvements in load factors, reduction in operational costs and paper-based processes, efficiency of reconciliation increased significantly, reduction of CO2 emissions, and other metrics that are mentioned there. As far as recommendation and dissemination, the project has generated, at the early stages, 4 position papers which have been broadcasted. We have identification of forthcoming international and EU and national legislative and policy initiatives. We are also actively contributing to now the consultation for the 10T corridors. We are preparing our contribution in the next few days. And we are also having here, similar to the previous case, 3 patents under development. Now, the materialization of the planet vision is what we call EGTN, is an integrated green EU global trade and logistics network. This is built upon a physical and digital infrastructure, utilizing secure and privacy-preserving data sharing infrastructure, knowledge models, PI services. It encompasses also disruptive technologies like IoT, blockchain federation, smart contracts, Hyperloop. And it takes into account also geo-economic context through simulations, KPIs, what-if scenarios. It addresses also barriers, possible barriers, geopolitical and trade and economic implications of the new trade routes, and of course tries to materialize operational excellence through optimization services, optimization in processes, and standardization. Now, again here, our test bed is 3 living labs. One built around the Asia-Europe-Mediterranean corridor with primary actors DHL and Costco in Spain, and where we are going to be applying physical internet and AI optimization. We have a living lab which is centered around the port of Rotterdam, which is looking about blockchain-based synchromodal dynamic management of 10T and intercontinental flows, also with promotion of the rail transport. And finally, we have a Silk Road living lab with center, let's say, area, the Poland, which is looking on the transparency and reliability of the China to EU corridor through the use of IoT and standards. This is also the case where we are using GS1. Now, the 4 position papers that were the starting point of Planet in the first 6 months were around the economic analysis of the dynamics and potential impact of new trade routes, looking them both on the macro and micro level, impact analysis of the new trade routes on 10T corridors and multimodal transport nodes, both from the economic and environmental perspective. We had a focused analysis on railway transport corridors to and from the EU. And finally, we had an analysis of the transition towards the PI paradigm, looking into disruptive technologies like blockchain, smart contracts, autonomous technologies, Hyperloop, and others. Now, Kostas will elaborate, give you some of the highlights of the project.
All right, thank you, Mikey. So whenever we are talking about the network and the infrastructure and trying to make these strategic decisions about how to develop the infrastructure, the technologies, and so on, it's certainly important to look into the shifting trade patterns. And those positions papers that at the start of the project helped us a lot to do that. The realization comes at some point that you have infrastructure, you have the ports, you have specific capabilities for the ports. Some of them are being privatized, but at the end of the day, the maritime routes are very versatile and they can also change, and they're not fixed. On the other side, when you're talking about rail infrastructure and rail connectivity from the east to Europe, we are talking about very large investments and infrastructure that cannot change much. But again, whenever we are trying to consider geopolitics in a model, you have to take all those into account. You have to take the Arctic route into account. You have to consider the One Belt, One Road, the north-south corridor that you see on the right here, and as well as the infrastructure, the ownerships, and the trade routes in the Mediterranean. So based on that, we started classifying these various characteristics in terms of social, economic, trade route availability, environmental aspects, political, technological aspects, and we came up with those 4 scenarios that you see on the right. And eventually what we've been trying to do is we've been using those 4 scenarios as projections for the European future. So whenever we are making a decision about introducing one new infrastructure, one new technology, we are trying to assess it in terms of those 4 futures. And therefore, we believe that helps us identify robust solutions. Now, when we're talking about strategic modeling, we have been covering multiple use cases, and we look both at the entry nodes of the network, so the large mega hubs, but also we're looking at the more hinterland warehouses, so smaller infrastructure, as well as the last mile. In terms of the technological offering, on the one side, there is the physical internet, the IoT tracking, blockchain, and so on. But we are also trying to consider technological advances such as the Hyperloop. And of course, we are always trying to compare all those with the possibility of just building new infrastructure. In terms of the external factor, that goes back to my previous slide about the different futures for the EU. And those 3 categories allow us to develop possible scenario for the future. Now, to make that decision about what type of infrastructure, we are also trying to incorporate multi-actor, multi-criteria analysis. So we've made a stakeholder analysis, identified all the significant stakeholders and logistics service providers and so on, and also the various KPIs and the weights that those KPIs have for them. So we are trying to identify solutions that are both robust and at the same time satisfy multiple user needs. Another aspect of the work focuses on the connectivity index. This is not something new in the sense that the connectivity index exists for seaports, but we are also appreciating the significance of having something similar for the inland terminals. We are developing this index for the inland terminals, and we are using multivariate factors such as the frequency of arrivals, the port capacity, infrastructure, and so on. As I said, we are also looking in the last mile, and here collaborative logistics is certainly important. So we've been working with DHL and Citylogin in Madrid to develop reshuffling algorithm for last mile logistics. So whenever a vehicle is running late, and cities do have this sort of uncertainty, we are offering options and help identify alternatives either within one company or through other companies that are operating in the vicinity to help and share the load and deliver on time. Lastly, a lot of analytics has to be integrated here as well, and operational decisions. So for the warehouses, we are developing predictive algorithms both for what arrives at a warehouse, but also what departs from a warehouse. And that allows us to apply AI, smart decision making for optimizing operations within warehousing, but also make projections about the spare capacity available, which is something that can be put out there for encouraging more throughput through warehouses. Finally, for the ports of entry and for the maritime decisions, again, in collaboration with COSCO, we are looking at the development of clusters of ports rather than ports operating in isolation, where one could potentially skip a port to allow hinterland to transfer the goods to its destination. So by tracking the load traffic, the estimated time of arrivals, the congestion at the port, a vessel can skip and can make a decision to alter its timetable. I think that's all from me.
Okay, thank you, Kostas. Okay, so one last, let's say, output of the project has to do with the application of blockchain interoperability. We have built a solution for that, which was based on another output of a European project called SOFI. This is an event-based synchronization between ledgers. We have applied that in a use case where we had the three communities: shippers, freight forwarders, and the port community. And at the particular example, we used the Hyperledger Fabric and Ethereum. And through this platform, we facilitated the exchange and synchronization of events. Now, as regards the mid to long-term expected impact, we see here the support of technological innovation and digitization of the transport logistic industry. We are enabling and project PI's added value both on environmental and economic dimension to all supply chain stages. We provide the tools and services to increase supply chain resilience. We inform policy and the infrastructure and technology investment in a robust and future way. And finally, we can support future projects with experience acquired in applying blockchain and blockchain interoperability in the supply chain, as well as the benefits of typical node points and the collaborative logistic models, in addition with micro-simulation methodology for evaluating the impacts of new technology implementations. Closing with the future research needs that we recognize from the project, we see the need to explore more scalable and secure blockchain interoperability frameworks. We are already investigating a framework called Cactus. We are exploring the modal shift utility of synchromodal solutions facilitated by IT. We see the need to evolve the connectivity, the corridor connectivity index, and investigate additional potential use cases and explore new types of intelligent PI nodal points. As regards market uptake, solutions that we see that have prospect to go to the market, we are already having a very mature solution in the Port of Rotterdam, UK connection with multimodal shipment information digitalization system. We have the IoT trackers and gateways which are designed to facilitate the envisioned end-to-end PI visibility. We have the intercontinental rate freight for sensitive and perishable high-value commodities as lead times and service quality improve. And we have finally the simulation of new technologies and impact assessment as a decision support tool for introducing and investing in new technologies. Okay, now, again, a bit loaded slide. The goal of the project is to provide a better understanding of the impact of emerging technologies on freight flows through models on the transport, through projected impact of autonomous vehicles, evaluating warehousing automation, evaluating blockchain impact, speed up the process and transition towards the PI paradigm with economic and the environmental impact of the PI in real-world business cases, and showcasing the level of effectiveness of the standardized PI logistic service providers application, enhance stakeholder capacity in governing the PI global trade web. We are also looking for better understanding of links between technology and trade and geopolitics, and improving the integration of the European transport network with global network. I went a little bit faster here because we are a bit running out of time. I apologize for that. So thank you very, very much for your time.
Thank you a lot. Thank you a lot, both Makis and Kostas. I think it's difficult to shrink so much in this small amount of time. Vasilis, if you want to take the floor.
Okay, hello. My name is Dr. Vasilis Soulas. I'm going to present you the next project in this session. It's called ICT for CART, which stands for ICT Infrastructure for Connected and Automated Road Transport. And the overall project, as it says specifically here, was to design, implement, and validate in real-life conditions and versatile ICT infrastructure for automation to enable the transition towards higher level of automation. So the actual target of this project was to have an ICT architecture/infrastructure that can provide and assist in enabling, let's say, the first two CCs of the SICAM activities. We're starting from connectivity in order to enable cooperation. And now might sound very straightforward, but back in 2017 that was written, in 2010 that started, was not very straightforward, but now it's pretty much as, let's say, the standard. In order to do that, we bring together and adapt, improve technological advances from different industries, as you see in the next slides, where we have all the partners involved in the project. And in order to do that, we integrate major wireless technologies, starting from all available cellular technologies. In the first half of the project, we were working with LTE, the known 4G cellular connectivity architecture. And in the second one, we involved 5G. And we also, this was combined in a hybrid mode together with the ITS-G5 short-range ad hoc communication architecture. As you can see here, this is the whole spectrum of the partners. The project, as we will show you later on, had 4 different sites. One in Italy. Actually, the Italian site was dual. One was in the city of Verona, an urban site, and one was on a highway, also in the Italian, in 22 highway, in the borders with Austria. The other site was in Austria, both in Highway 1 and in a cross-border setup in the Italian-Austrian borders. And the third one was in the city of Ulm, an urban site where Nokia played a major role there as mobile network operator and vendor. As you can see, in all sites and in the project, we had the full spectrum of partners, starting from tier 1 like Bosch, starting from vendors like Nokia, which also played the role of mobile network operators, and mobile network operators like the T-Mobile and the Wind in the different sites. So in each site, we had all the necessary expertise, but at some point it was a little bit conflicting because from where you stand, people had different views of, let's say, for example, I give you that the mobile edge computing or the multi-access computing, which is now the MEC, road operators had totally different view of what it is a MEC compared, let's say, to the mobile network operators. It took us some time to reach an agreement there. We have 21 partners from different countries around Europe. The project initially had 36 months of duration, but we had to extend it due to the COVID restrictions on traveling and mainly for visiting the sites. And it ended actually last month, and next week we have actually our final review. Here is the full objectives of the proposal, and pretty much each bullet point drove all the work done in the project, starting from identifying, of course, the most functional technical connectivity requirements, implementing standard-based distributed IoT environment for data integration, implementing a cybersecurity and data privacy in all the corresponding use cases. A key point was to improve localization that combining information from different sources, both from, let's say, satellite GNSS and from RTK messages that were supported by the mobile network operators. And of course, this ended up with extended validation and demonstration events. Unfortunately, also due to COVID restrictions, we didn't have the chance to have large-scale public events as was initially planned, but we had appropriate demonstration validations videotaped and available soon in the site of the project. Of course, this was finalized with new business models and market services, and as well as a quite rich, let's say, standardization impact of the project overall. Here is the activities carried out. In the right part, in the picture, you can see, let's say, the whole spectrum of the high-level architecture of ICT4CART. This doesn't mean that all sites had all the specific attributes there, but it is what we wanted to show is that we have designed a modular and versatile infrastructure that, based on the needs of each use case and based on the capabilities of the corresponding infrastructure, both at the road level and in the network level, you can have, let's say, a snapshot with different attributes from there in order to provide the necessary capabilities to support the corresponding service. I'm not getting into more details since the next slides will show you some more details of this high-level architecture of ICT4CART. It was the architecture was divided in different views, as we saw later on. The first view is the functional view. Here, this layered, let's say, in boxes, depiction is only for representation. It doesn't mean that you need to have this kind of architecture, but you can see here the full functional attributes that can be combined using the ICT infrastructure in order to provide and support, let's say, a use case. For example, you can have, let's say, 4G or 5G communication modules using the corresponding technology and using, let's say, corresponding CITS services or geo services in order to support, let's say, a smart parking or a fleet management use case. So you pick from there the different functional components in order to build your service. And this is something that we think at least that it's very forward-looking, because in the next calls, in the next 5G-related calls, there was a specific call regarding this modularity thing in order to combine different functions in order to build, let's say, a network application. The next view of ICT4CART, it's the communication view. In this simple picture here, you can see the different communication aspects that were used by the project. You can see here that vehicle, all the roadside units or the signals along the street can use different technologies, both based on cellular and both on ITS G5 short-range communications, and they can also be combined together in order to extend reliability. The next view in the ICT4CART architecture is the IT/data service view, where you can see the whole, all the different flows, how the different flows in the different use cases ICT4CART take place. You can see here that you can have messages, let's say CAM messages, using either ITS-G5 from the cars, from the vehicles, or using any of the cellular connectivity options. The RSUs can, for instance, communicate directly with the cars, or with the MEC, or with the cloud, where, let's say, an OEM service relies. So any different combination that you can imagine has been included in the overall design of the ICT4CART architecture, but has also been examined and tested in the different use cases. Also, we used different messages because of the different needs of the different use cases that require different, let's say, characteristics, both in terms of bandwidth, in terms of reliability, in terms of latency, so on and so forth. I forgot to mention that in the bottom of each slide, you can see the corresponding deliverable, which is strategically were designed to be small enough so that you can get all the necessary details. All of them are public, and you can find them in the ICT4CART webpage. And final, last but not least, is the cybersecurity and privacy view, where here we had to find a solution to secure, let's say, the transactions, but also make them anonymized, because nobody wants to know where your vehicle is and you don't want to share this information. So we designed both an identity management service and an EM solution and an anonymization scheme. This was done by Airbus, as it was the main cybersecurity and privacy contributor in the project. All those were combined and tested using 4 different use cases. In ICT4CART, you use the term use case as an overall, let's say, service, and the term scenarios, where the specific use cases were examined in different sites in order to check this interoperable and modular architecture. As I mentioned at the beginning, we have 4 different sites, one in Austria, in Germany, and in Italy. Actually, in Italy, it was a dual one, both urban and highway, and the cross-border between the borders of Italy and Austria. And the 4, let's say, category of use cases are the smart parking and IoT services that were examined both in Germany and in Italy, using different technologies there. The dynamic adaptation of vehicle automation level based on infrastructure information both in Austria and in Italy, mainly in highway scenarios. And use case 3 was the intersection crossing and lane merging use case that was examined in all different sites. Use case 4, which is the cross-border interoperability, was significantly enhanced along the progress of the project. And it was, let's say, similar to the highway and lane merging use case, but when you are crossing the borders between Austria and Italy and you have to change the networks from magenta network on the Austrian side to the wind one. For the cross-border one, we had a close collaboration with the Sea Roads project in Austria in order to use their facilities, and they also used our facilities for their demonstration events. And here you can see the different scenarios. I'm not going into the details because the time is running, but in order to have to check the interoperability of the infrastructure, we used the same use case with different scenarios in different cities and different setups to showcase that everything can be done using different combinations of solutions. This is the expected long-term and short-term impact as it was stated in the project. Some of them are implicit, some of them are explicit. I'm not going to stay here, but I'm going to spend the last minute that I have in this last presentation, which is I've cherry-picked some key measurable impact points. From our perspective, it is a pioneering project in the automation let's say, ecosystem, this project, because something that it's prerequisite today, the connectivity and the cooperation between the vehicles. It was not very straightforward back in 2018. We have used both LTE and 5G together with the ITSD5 to showcase that this hybrid solution is feasible. We have enhanced the precision of the GNSS using these RTK reference stations in more than one sites, and we managed to have accuracy of up to 1 or 2 centimeters, which is very significant and very important for the level 4 and above automated cars. We also had a lot of interactions with different standardization activities, both with HETR 102638 in order to provide the parking availability notification service and in order to introduce a new kind of CITS message there, as well with the CITS Working Group 1 for the cooperative perception services in order to produce the extension of a current message which is called CPM. Another measurable impact that it is nice to mention is that this project has, let's say, influenced the 5G ANA project that is actually running now. And a newly funded project that was submitted last September under the D60103 call, Physical Digital Infrastructure, Connectivity, Cooperation, Enabling and Support SICA project, which is called Podium, and it is to be started later next year, which can be considered as an, let's say, a continuation of the ICT4CAT project. So that's it. Thanks a lot.
Thank you.
So thank you very much, all the speakers, for shrinking so much information. I think we have now the time for a Q&A session. I will pass the floor to Torsten, so we will steer a little bit. I think there will be questions from the public. So please go ahead if you want to ask something.
Yeah, okay. So thank you all. This was a whole word of wisdom encapsulated in these 3 presentations. But now we have some time for questions from the floor. And I would like to invite you cordially. Mics are available. Please stand up and raise your name. Anyone? Yes. Let's start in the back, then in the middle, and then I recognized a third one here in the front. Okay.
Thank you so much for great presentations. My name is Josephine Darlington and I work at Drive Sweden. And I've written down my question here. It's quite long, but it's for ICONET, both projects. we were discussing here what the difference is, what the project has done in comparison to transport administration companies, like Enshift, for example, who work a lot with DHL and the at least Swedish transport companies such as PostNord. And are you then connecting the different transport providers so they can use the respective infrastructure? You mentioned DHL and Costco. Are you optimizing the system for the respective transport providers, or is it for the system in the totality? That's the question.
Thank you. That's actually a good question. So the answer, I think, is both. And you have to look both at the operational aspect to understand, how the current business models are and what the companies are doing at the moment. Help them potentially improve their business because, this is, I think, what will bring companies to collaborate, share data, move into this new paradigm of operations. And at the same time, you are trying to project, all this understanding of the individual operators into a strategic level. And this is actually exactly what, so Iconet wasn't doing that as much, but Planet is this is exactly what it's supposed to do. So it's trying to figure out, considering all this functionality, all this existing know-how, how do we convert that into a strategic, higher level, system that we can work around and make it more efficient.
So just so I understand you right, by showing the potential of how they could work together and become more efficient, you're hoping that they open their infrastructure for each other to work more together?
Yes, can you repeat? Sorry, that was...
No, I'm just saying that by showing that there is the potential to work together and optimize their respective flows together, then you're hoping that they'll open up to actually do that in reality.
Yes, certainly. So, there are various criteria. It's not maybe that simple because, the data that each company has in their silos have other functionalities as well. But yes, in principle, I think, solutions like, having an additional warehouse, opening it up is something that a company can do in isolation at the moment and, benefit. And also help towards participating in a larger extent in the integrated network, in 10 years' time. So I think, yes, there is certainly a connection between, achieving benefits at the moment and also working towards this integrated system.
Thank you so much.
You're welcome.
Okay, so my name is Rune Søråsen from ITS Norway. I think this is more or less a follow-up on the previous question, and it's towards the Iconet project. In the project, I see that you have made great progress towards the implementation of physical internet, but have you done any work to identify potential barriers, mainly related to societal and business issues towards large-scale deployment?
Yes, certainly. So it is an ambitious project, right? So when we are talking about the physical internet, it is not even entirely clear. So for data, maybe it's simpler. For data, you send them, someone else receives them, it goes from hub to hub. It all kind of adds up. For the physical internet, it's certainly, much more complicated. You have many stakeholders, you have many problems. So I think the trickiest part, the trickiest challenge, again, in my view, through those two projects, is not actually data. The trickiest challenge is enabling, the stakeholders, first of all, to see the value and understand how they can participate in this collaborative environment. So data is there. They either share it or not. Someday it will happen. We don't know when, but it will happen at some point. So I think the tricky point is actually, bringing all those stakeholders, explaining the value, taking into account their perspective as well, because, this is important for them to collaborate. We need to respect that. And it might not happen as a federated solution that, the entire European Union participates in it. It might be something smaller. But what's important, I think, is that, the principles of the physical internet get through the current operations and, the efficiency that is associated to it
is delivered in practice and in the physical world.
Just to expand, we showcased again the collaboration of various services in various dimensions of the flow. And the idea was to allow them to understand what could be the potential role of those actors. I mean, for example, the Port of Antwerp could be a service provider, giving information on the status of their warehousing, of the status of the network. So the various actors could recognize their role in this network and see the role they could play. Definitely barriers were recognized. And even the sharing of the data is not as simple as it said. I mean, sharing of data is something which is a lot harder, and unless there are obvious benefits, nobody is really willing to share any data. So the barriers are there, the trust, the lack of trust is also there, but I think through this kind of collaboration and through this kind of demonstrations, you are starting lowering the barriers and make it a little bit easier for people to digest that, okay, I can share some information, my spare capacity, my spare demand, and maybe I can benefit from that. Let's see how we can do that.
Thank you.
Good afternoon, Hein Franken, TNO, the Netherlands. I have a question for the third speaker on ICT for cards. You had a great project integrating both telecoms and ICT. What were your ways to deal with latency differences if you have different times of arrival of different packages?
Yes, you mainly mean about when we're using hybrid solutions, when you both use both channels, probably.
Yes.
Yeah. Okay. I cannot recall now all the necessary details, but usually we use only one of them each time. So the second one gets into when one of those are lost, and mainly in the cross-border scenario when we use both interfaces. But I think this also goes to the way the messages are constructed. They are the different CITS messages about when you are getting when you're receiving them out of order. So it's something that it has not been solved by these projects per se when you use different solutions in the same time.
Yeah, it's a challenge.
It's a challenge, yes, and I think this is a challenge also that mostly has been looked by the projects that are doing these cross-border things in the 5G area, like the 5G Mobix, like the Croco and all the stuff. But in our case, the use cases were not that demanding. What we wanted to do is to make sure that the connectivity to the MQP broker is constantly there. So it was not that crucial to have, let's say, continuity of the specific service, like a video or like a high stream or whatever. So, I mean, a small interruption, it was okay because the use cases were not that demanding in having this kind of continuity. But it is...
Ongoing.
It is demanding.
Thank you.
Guus Arts, DAF Trucks. Also having a question for the third speaker. What are the typical use cases that you're looking into? Is that to support the connected and cooperative part of CCAM, or is that also related to the level 4 automation you were also talking about? What kind of use cases?
Yes, the project objective was to support use cases up to level 4 connectivity. So let's take a specific scenario. One was the lane merging in the city of Fulham. There was a specific cross that was totally blind from the perspective of the autonomous car. So with the use of infrastructure and the cameras and the leaders that were included in the infrastructure in some poles, the environmental perception model was much richer and could do this crossing of the cross in an autonomous manner with level 4 capability. So the target was level 4 overall, also in lane merging or in the toll approaching use cases.
Okay, so if I summarize correctly, then the use cases that you've investigated are there to support level 4 applications on the public road.
Yes, this was
emerging from the infrastructure.
correct. With the support of the infrastructure and, of course, with the use of the vehicle sensors, the idea was to support up to level 4 of automation. Now, in the continuation that I mentioned, the next project that it comes, the idea is to use the sensors of the vehicle surrounding or the VRUs or whoever is participating at a specific piece of the road when in order to support the same level of services when there are no any infrastructure solutions like cameras or lidars in poles and things like that. This is very demanding, but it shows that it's not always necessary, or it might not always be necessary to have a fully fledged, let's say, road with all the necessary sensors to support this kind of actions.
Okay, thank you.
Yes.
Good afternoon. Thank you very much for all the presentations. Again, a question for number 3, the ICT for CART. Magnus Granström, the SAFER platform. You mentioned the VRUs, the vulnerable road users. Could you elaborate a bit more on how they contribute and also how they can benefit from your results?
Yes, VRUs are not in part of this project in ICT for CART. It is part of the extension, let's say, of the ICT for CART project, to the project that is going to start in a couple of months, September actually. But I can give you an example. The VRUs usually carry a mobile phone, so the idea is to use this kind of connectivity using their mobile phones mainly in order to participate in the overall service. One solution is to provide, let's say, by capturing their path, their mobility pattern, and send them alerts if they are to cross street, or send alerts to the car, to the automated car that is approaching a VRU. And the other way around is to use the sensor of the mobile phones to be part, let's say, of the perception model that is going to be built around this specific piece of street. But it is to come now. It's not. It's under development.
Okay, thank you very much. And I assume also the anonymization and so on.
That's
also a crucial part of
yes,
the project.
It's still there, correct, and it's even more enhanced now.
Thank you.
Good afternoon. I'm Shekhar. I work with Global Logic Hitachi in Poland, and my question is again to the ICT for CART. Now, I understand the objective was to meet level 4 of automation, but I personally believe that as we progress in future, it would be more or less that a human being would become a passenger, a pure passenger. And that's when that would happen. One of the perspective which I think of is the safety of the human being. And the two aspects would be one being functional safety, and second being something like a e-call initiative. So are we already thinking of prioritizing such messages over the network systems?
Okay, I'm not sure I understood the question exactly, but look, the target is level 5. There is no steering wheel, there is nobody in the car, we are just sitting back. But I'm not sure that we are going to be there very soon, at least in my opinion, and based on what I have seen in ICT for CART and in the other projects. But the idea, first of all, is to increase, firstly, the safety of the current levels and level 3 or level 4. So taking from there, I mean, we can move to next levels. But I don't think that I responded to your question, because the question was a little bit different. If you can
allow me to reframe the question.
Yes, please.
So we already know that once the protocol is any of the protocol or any of the specification, when it is suggested, it takes several years for it to be published and then come into force. So are we already thinking of a protocol or a specification which would allow emergency messages getting prioritized over ICT networks?
Okay, yeah. Look, I'm not aware of any specific specifications, but I think that in release 18 of the 3GPP about 5G or 6G, there might be some kind of solutions there. But one solution that I think is there, and we have here in the audience plenty of MNO represented, is the different slicing of the network. So you provide a specific slice with specific reliability and quality measures to any kind of use case or any kind of use that you want. So you prioritize pretty much there the messages, the safety measure, whatever is the message. So the idea is, let's say, let's take an example. You have an ambulance that wants to reach, let's say, the hospital, and it needs to get there and stream videos of the passenger there or whatever it is the case. So you can now, I think, with the 5G and the 6G capabilities, you can provide very fast a slice across, let's say, the corridor that the ambulance is going to travel in order to provide the necessary requirements and quality indicators to support the use case, which might be either streaming of high-definition video or if the ambulance is level 4, even in that case. So I think the solutions are there, but on specification standardization, I think there is nothing specific now on the AVs overall. There are here and there different standards on cybersecurity, on transportation, on telecommunications, but nothing specifically on that part.
I understand. So I'll park my thoughts now. Maybe we can discuss this later. Thank
Yes,
you.
of course.
Thank you much for the presentation. My name is Janez Humor. I'm coming from LS. With respect to the agenda of the 2.0 partnership, my question goes a little bit into the direction that was not opened yet today. It goes a little bit into the sustainable transport and on the, let's say, your potential future role into the support of the sustainable transport. What I have in mind is, since I'm coming from the transmission system operator from the electricity, and we are well aware that sooner or later the let's say electrification of the road transport will come. What will be actually the role of the ICT support to this? I would call it like a sector merging of the electricity and of the transport, because especially when you would like to somehow integrate the data of the availability of energy for the charging of, let's say, trucks and buses and all other sectors with the, let's say, some sort of the expectancy of the transport sector, of the logistic companies, what will be the impact of this, let's say, different cost, different availability of the charging to their normal operation. This question, of course, goes more to the first two presenters. So if I be more specific with the question is, did you perhaps intend also in the, let's say, in the future work to also integrate the data from the, let's say, power sector to give more information to the logistic and the transport companies about the, what would be the perhaps best locations for their warehouses, let's say in the proximity of the high power infrastructure to support the charging, and what would be the impact of the quite, let's say, fluctuating cost of the electricity to their normal operation. So more in this sustainable transport. This would be my question. Thank you very much.
I mean, that is a very interesting comment. First of all, no, we haven't, as far as I know, explicitly looked into it either in ICONET nor in Planet, but maybe through the development of integrated data platforms, you know, this is something that can come in and through, again, developing maybe even predictive algorithms to as much as possible predict the flows at a specific corridor, and then linking it to smart decision making to have an answer for it. But at the moment, no, we don't really have an answer for that, to be honest. And as I said, that's a really good suggestion. Thank you.
It will be an additional constraint in all the variables. I mean, the same way whether we were trying to predict where the warehouses should be placed for better distribution, you have one more constraint in the future: where are you going to power those vehicles if they are electric? So this adds the complexity, but I think that it makes the problem even more interesting. But at the moment, the two projects are not dealing with that.
We are already working on a project that will
prepare some sort of either modeling and simulation to merge power and the transport sector together. But of course, on the transport part, you are much more advanced in this direction, so perhaps we can talk.
Yeah, I think this is definitely a great idea for future projects and future research. Yeah, I agree. Absolutely.
So, future. Time is flying, lunch is waiting, yeah? So, with having said this, thank you so much to the presenters. Please give them some big hands for excellent presentations. I would also like to thank my co-chair for the session, Mr. Andrea Acelli, for his kind introduction. And I would like finally to thank you for your lively contribution to the debate. And now, without further ado, enjoy lunch and enjoy the entire conference. Thank you so much.